And standard deviation has the same units as returns, so I can actually express them as percentages. Let me do this a different color. Right. And make this also a different color. Something like that. In fact, I can even change their locations. Cut, insert, cut cells. Because I'm not directly interested in variance itself, we're interested in standard deviation. And I'm going to reduce this to mean. That's another name. Let me make a note of that. It's sometimes called the mean of the distribution. Why do we think of standard deviation as a kind of risk measure? This goes back to actually late 1700s. Have you guys heard of the mathematician called Gauss? Euclid Gauss? He came up with the so-called Gaussian distribution, which is nowadays we call the normal distribution. And if returns are normally distributed, we can use the so-called empirical rule. It says that 68% of the time, outcome will be within uh, plus minus one standard deviation. Or about 95% of the time within two standard deviations, and 99.14% of the time within three standard deviations. Now let's consider two return distributions. With the same mean of, let's say, 10%, but the first distribution has a standard deviation of 10%, and the second distribution has a standard deviation of 15%. Right? And let's ask the following question. what is the probability that uh, either one will have a return that is less than negative 10%? Consider the first one. Negative 10% is actually, let's do negative 15%. So that arithmetic works fine with the empirical rule. And let's make these 5 and 10 to make my job easier. For the first one, relative to the mean, to get the negative 10. Mean is 10. Huh? Mean is 10. To get the negative 10, how many standard deviations do I need? Standard deviation of the first one is 5. So 10, to go from plus 10 to negative 10, I need to go down 4 standard. Okay? Is 4 standard deviations of the mean. For the second one, negative 10% is 2 standard deviations below the mean. We can actually calculate these probabilities using an Excel function. Using an Excel function, probability that x is less than negative 10% is equal to norm dist negative 10%, mean sigma true. Let's go ahead and do this here. So x value probability that x is less than x value small x negative 10%, 10% for the first one, 5%. And I'm going to use the function norm dist, control A. X value is the x value, the mean, standard deviation, and the last argument is cumulative. And you need to say true to get the cumulative. Let me write that as a percentage. Basically, the chances of that happening is only 0.0032%, or about roughly 3 in 10,000. Yes. Oh, okay. Sorry. Don't worry about it. The second one is, I'm just going to copy and paste. But this time sigma is 10%. That's why we think of sigma as a measure of risk. If this was 20%,